Strength through numbers.
Yeah.
Yes.
And unity. And identities.
And
To infinity and beyond.
Woo!
All right, here we go. Okie dokie. So, our favorite thing, this is all the trig that we've been doing all this time is for this moment.
And it is here.
We are so excited. This is our favoriteest part, which means we're going to like it on the test. Okay, so we're going to solve this equation. First of all, it looks horrible because we have both cosine and sine. We got cosine of a double angle, which means we need to change that. So let's look at the
Wait.
What?
I don't like sines, cosines. Sines and cosines
I
in
know.
the same. So is there anything we can do to change that?
Well, we have 3 identities for cosine. The question is, which one do we use? The fact that this is a sine tells us we need to use the identity for cosine, that is cosine of 2x equals 1 minus 2 sine squared x. Okay.
Oh, okay.
So, hey, how can you remember if the cosine of 2, if we're going to, the formula cosine 2x equals that, or cosine 2x equals 2 cosine squared x minus 1? I mean, besides the way you could generate it, but the thing is this, cosines like each other, so they want to be closer together, and they'll be positive. Cosine and sine, they're always fighting against each other, so they're going to be as far apart as possible, and they're going to have that negative because there's just a negative energy there. Okay, there's your New Age lesson for today.
Okay.
All
All
right,
right, so we're going to replace cosine of 2x with 1 minus 2 sine squared x. And the nice parentheses, just to help us see where we put our stuff into our equation.
And you know, so many of you, if you just would be really meticulous in your work and do things like show parentheses, it helps keep it organized, and then you can follow what you're doing. A lot of times you get lost in what you're doing because you can't follow your own work because you haven't been neat enough. So let's work on that. Okay.
All right, so now, if you notice, we have a sine squared x and a sine x, which means this is going to look quadratic in nature when we're done. So we need to go ahead and move that 3 over so that we can either factor, if possible, or use the quadratic equation.
Yeah, I could move it over, but the thing about it is I see this negative quadratic
Oh, you
here.
just want to move it so that everything...
Why did I just write this statement in green? Because if I had a number in front of here besides 1, I'd have to distribute it. But I don't have a number there in front of the parentheses, so I don't have to distribute it. So this step right here was just for the purpose of removing the parentheses. Now we're going to move everything to the right-hand side.
So that we have everything, so we have the squared term positive.
Yeah, because I like that a lot better. 2 sine squared x, then that's going to make this minus 5 sine x. And when I move this 1 over here, it becomes negative, so that's going to be plus 2. Now, a lot of you immediately start doing the
quadratic formula,
which is silly. So if our u is sine x, what we're looking at here is 2u squared minus 5u plus 2 equal to 0. Now, here's the thing. There is only only one way to factor this. And the thing to think about here in this problem is, yes, if you want to use the AC method, that's fine, but this is an easy enough problem to not do that. Notice that there is only one way to factor 2u squared. That is 2u and u. And there's only one way to factor 2. That is 1 and 2. And notice that there is no GCF here. So since there's no GCF, the 2 of my 1 times 2 cannot go there. It has to be a 1 here and it has to be a 2 there, because if I could put the 2 in this parentheses, I have a greatest common factor, and if I have a greatest common factor here, then I would have had it in the whole thing, but I do not. That is how you start factoring in an efficient and more
faster way.
Yeah. So this is going to be that.
I know that the signs are both negative because my C term is negative, and
my C term's positive.
I mean, C term's positive and my B term's negative.
Yeah, so this is 4u, this is 1u, and 4 plus 1 is 5, so that works. So now we can see pretty quickly that over here, if we use this pattern here, I'm not going to actually use the u step here. I'm going to go straight to 2 sine x minus 1 times sine x minus 2 equals 0. Now we have 2 cases. This is where some of you get really sloppy in your work, and it's really unacceptable. So here's what we want. We want you to set up 2 separate equations. That's the first thing we want to see. Oh, not that. Okay.
Sine x minus 2 equals 0.
Now I can see that the one over here on the left is going to take me a little more work, so I'm going to look at this one on the right. Sine x equals 2. Sine x equals 2. One of the things you're supposed to know is all values for sine and cosine must be between 1 and -1, so this factor has no solution. And that should be something you don't even have to think about at all. Okay, over here, we're going to add 1 and divide by 2. You should not need to show both of those steps. Now, what we have here is we have the sine of our angle equal to 1/2. Now, I'm going to go up here and say, what does it tell me to do up here in this problem? Am I being told to put it on the interval of 0 to 2 pi?
No.
Was that asked?
No.
No, it wasn't, so I don't have to do that. What that means, since it wasn't specified, is I want all solutions. All solutions means plus 2 pi k. So, you should know by now, when the sine is 1/2, that is your y value of 1/2. If you have to think about it this way, you can have the y coordinate to be 1/2 and your x coordinate can be positive or negative. So think about if the short side of the triangle is your y side, you have a 30-degree reference angle. So the angle you want to write is pi over 6 plus 2 pi k. Okay? Now, that would be how you would answer part of it. But the thing is, there is another quadrant where the sign is positive 1/2. And this is where you guys are making some mistakes at the step where you do this step. I'm going to erase this because there's something I didn't write and I want to actually refer to that. Ms. Miller and I both want to talk about this. The sine of our angle is 1/2. So x is the angle whose sine is 1/2. At the step where you evaluate the inverse sine function, okay, which was when I said pi over 6. And generally, you really should always be thinking in terms of plus 2 pi k. We'll explain that a little bit more later. But you have another solution. And the other one is, so x1 is pi over 6 plus 2 pi k, and x2 is always, for sine, pi minus your x1 plus 2 pi k. So now we can fill that out a little better. x2 equals pi minus pi over 6 plus 2 pi k, and we expect you to write what that is. x2 equals 5 pi over 6 plus 2 pi k. So the first thing we want to see is, did our two answers work? And that is, our angle is in quadrant 1 or quadrant 2 where sine is positive. Did that work?
Yes.
Okay. Now, if we were asked to find on the interval of 0 to 2 pi, now why do we not include the 2 pi when we do this?
Because 0 and 2 pi are the same.
Yeah, they're at the same place on the
place.
circle. They're not at the same place when we graph this function as a function, but they are coterminal angles. They have the same sine value, so they fit that requirement. Okay, here's the thing you really need to think about. Notice I said that you really pretty much, anytime you evaluate the inverse trig function of some angle, and you're finding the angle, you really need to think about this. And now let's evaluate for specific values of k. So, if k is equal to 0, x1 equals pi over 6 plus 2 times pi over 6, not pi over 2, silly, I was already under the 2, pi over 6 plus 2 times pi times 0, so that term's going to drop out. So if k is equal to 0, x1 equals pi over 6. Okay, if k equals 1, what do you have? x1 equals pi over 6 plus 2 times pi times 1 is 2 pi. Well, guess what? That is out of the interval that we established, which was, let's put it here.
Yep.
So I would not have to do anything with that. I would be done. Okay? Now, there are times, like when you saw in the last exercise, last class activities, where you had to divide through by 2 or 3 or whatever, and then you got more possibilities. So you have to be precise. Now, if k equals 0 in this one, I can see that x2 is going to be 5 pi over 6 plus 0. And if k equals 1, I'm already too big, so I don't have to worry about that for this problem. So if we were answering the question, put it on the interval of 0 to 2 pi, the two answers would be x equals pi over 6 and 5 pi over 6.
If we were going from 0 to 4 pi, we would just have used the k equals 1 and the for both of those, and those would be our solutions.
And you know what? We can do that. So be sure that you pay attention to that one, that idea.
Okay, so the next one is we're going to solve 8 sine x cosine x equals 5. But I don't know how to do this with 2 different trig functions.
Wait, we have an identity that multiplies sine times cosine, but
Yes.
it doesn't have 8, it has a 2.
Okay, well, I know that the one that multiplies sine and cosine is sine of 2x equals 2 sine x cosine x. Do you see why you need to know them backwards and forwards? So what I can do is I can say, okay, well, 8 is really 4 times 2 sine x cosine x. Okay, and that would equal 5. So 2 sine x cosine x can be replaced with sine of 2x. So I have 4 times sine of 2x equals 5. Now that I have that, I'm going to go ahead and divide both sides by 4. So I have sine of 2x equals 5/4, which, if you know, sine has a restriction from, it starts, the max is 1 and -1. Okay, so we have a restriction from -1 to 1. So just, even though it's 2x, it doesn't matter. Okay,
Yeah,
because
this is
theta.
any angle, whatever that angle is.
So this has no solution.
And the reason that is, guys, is sine is y over r. Y is never bigger than r. It can't be. So you cannot have a ratio that would have that requirement.
Another thing you can do to think about this, if you're kind of confused about the 4 times the 2 and how I broke that up, over here what you could have done is said, oh, well, I know this is in my equation, so I could do sine of x cosine of x equals sine of 2x divided by 2. And then instead here, at this step, I could, well, if you don't know how to break it up,
Yeah.
you could break it up here, and so it would be, I'm going to show it in blue over here, okay? This would be 8 times sine of 2x over 2 equals 5, and then that 8 and that 2 would simplify to 4.
Yeah, that's good. That's a good point there. Good point. Okay, exact solutions. What does exact solutions mean? It means don't use a calculator. That's what it means. All right, so notice that what we have here is 2 sine x cosine x. So if you're really smart, you recognize that as sine of 2x. Cool. I love sine of, my double angle for sine is my favorite one because it's so easy. All right, how are we going to do this?
Well, we can go ahead. We already know.
Factor out the 2. Factor
No,
out.
you can't do that.
Oh,
First,
two eggs.
we're going to solve for 2x. So we have 2x equals the sine inverse of 1/2.
Now remember, this means the angle whose sine is. So the very next step we should have is some angle. If we were doing this on a calculator because it required it, we'd get some decimal number, okay? We're going to get some pi number, but please don't be afraid of the fact that sometimes you have pi and sometimes you don't. They're all still angles.
Okay, so now we have 2x. This is important. 2x equals pi over 6, because I know that the sine inverse of 1/2 is pi over 6. But I'm going to also include the plus 2 pi k. Okay?
The reason we're going to do that is because of that.
Yes. Okay, so wait. We have another value in quadrant 2, which would not be the principal angle, but it's still important. So we've got
the reason it's important is because we're thinking about our circle.
the whole. These are all of
them.
them.
Here and it happens here. We got to include every possibility.
All right, so we also have 2x equals 5 pi over 6.
We're not going to show you how we got to 5 pi over
Plus
6. You should know that by now.
2 pi k. Now, in order to solve for x, we're not done. We have to solve for x. We have to divide everything by 2, or multiply everything by 1/2. It's the same thing.
Yeah, and it's easier if we multiply by 1/2 because then you really see that the half gets distributed. And since the half gets distributed, that's going to let you see that we're also getting pi k.
Now, this is important because now all of a sudden we have more iterations.
Okay, and I'm going to go ahead and go to, we have iterations. So this is our general solution, okay? general solution. I think he was in some army somewhere. Okay, and now I'm going to
divide by
do
2.
the same thing. Notice how we're specifying x1 and x2 because we're going to be talking about 2 different independent values. So
plus pi k. Very important. Okay, so these are our 2 general solutions, which at this example, since we were not asked to find in a specific interval, we would be done. But what if we asked you for 0 to 2 pi? Well, for x1, when k is 0, we would have x1 equals to pi over 12. If k is 1, then x1 would be pi over 12 plus pi, which is still in the interval.
okay, I had to explain this to somebody yesterday, and so here we go. Pi, this is 12 pi over 12. So we're going to think about this like this. I like pizza a lot. So if I took a pizza pie and I cut it into 12 slices and I ate all 12 slices, but I was still hungry and I wanted one more slice, how many slices would I have eaten?
13 slices.
Okay, guys, you got to be able to do this. Okay, this is still in our interval. How come that's still in our interval?
Because we're going from 0 to 2 pi, and 13 pi over 12 is actually, okay, so if we thought about it as 2 pi is 24 pi over 12, that would be 2 pi. 13 is less than 24, so it's still in our interval.
Right, at pi, we're at 12 pi over pi, so 12 pi over 12, so 13 pi is here somewhere.
If I added another pi, I would
over
be
12,
at pi over 12. I would if I added another pi to that, I would end up going to 25 pi over 12, which is past my interval, so that would not be in the solution.
Yeah, and that's a good thing to think about. Again, guys, you know how to do this because we know you passed elementary math. So you can do it. Don't let that silly little pi throw you off. Okay, now let's come to this one. When k equals 0, x2 would be 5 pi over 12.
Good.
When k equals 1, x2 would be 5 pi over 12
plus pi,
which is 12 pi over 12, so x2 would be 17 pi over 12. But I don't really know where that is, so now I'm going to think about this circle real quick, because here's how you think about this a little bit more deeply. If this is pi, that is also 12 pi over 12. Well, we know that this is pi over 2 right here, which with a denominator of 12 would be 6 pi over 12. And if this is 6 pi over 12, add 6 pi over 12 to that, we get to this. Add 6 pi over 12 to that, we get to 18 pi over 12. And notice 17 pi over 12 is still in this interval.
In that quadrant.
Now, some of you are saying, but it said that sine is positive 1/2. How in the world can we be in this quadrant? Because, when we double an angle in this quadrant, we actually end up, so when we double this, we actually end up in, if I take pi to 3 pi over 2, and I multiply that by 2, I end up in the interval 2 pi to 3 pi. Well, where's 2 pi to 3 pi? Here is 2 pi. Here is 3 pi right there. And look, are our sign values positive in that quadrant? They certainly are. So it agrees with that. Now,
one thing I wanted to show you really quickly was we already graphed these functions on our interval. And what does that 2 in this 2 sine x do? Well, it changes the period. So if this is 2 pi, okay, normally we would go like this. That's one period. But now, since we have 2 pi, our period is halved, so now we're going like this.
So you're seeing 2 cycles in the standard 2 pi interval. Now, what isn't changing is the max or minimum's not changing. So this is still here. So let's say that we're still going to 1 and we're still going to -1. So
my red needs to be a little steeper.
Yeah, but you get the point. The point is that 2 you should recognize because we talked with you about it. That means 2 cycles.
So on the black one, I only had a positive 1/2 1, 2 times. But on the red one, I have that positive 1/2 1, 2, 3, 4 times. So I should have twice as many solutions. So you can think of this in multiple ways. You can think of it as the unit circle. You can think of it as the graph that we've done. All of this stuff connects. You have to be able to connect the information so that you can build a full understanding of what trig is actually about.
Yeah, and that's the thing is if you're trying to, well, when I see a problem, I memorize this is all the steps I do. That is not going to help you. If your tutor, if you have one, is helping you learn it that way, that is not going to help you. So you need to readjust how you're doing it.
Okay, so the next one is we are going to find the exact solutions of cosine of 2x, cosine of x, minus sine of 2x, sine of x equals
Hey,
1, -1.
that looks like cosine A, cosine B, minus sine A, sine B, and that's cosine, cosine, sine, sine, and that would be the cosine of an A and a B, and cosine changes that. So that would be that identity.
Yep.
So you have to know these
Backwards. Front
guys.
ways and back ways.
So what's my A going to equal, Ms. Miller?
2x.
And what's my B going to equal?
X.
Okie dokie. Here we go. I am using this pattern. I see that this is in this pattern, so I can go straight to that as long as I've shown that that's what I understand. So I am going to let this be cosine. My A is the 2x. I'm going to show that step of substituting the A, plus my B is x. And I want to show that this is equal to -1. I'm not sure if we're going to move that -1 over or yet, not yet. So let's just see where this goes first, and then we'll make that decision. Every decision about a problem does not have to be made at the beginning.
Yes. It's like,
So
do you decide what kind of sinks to put in your house before you build? Or do you decide the faucet color or the doorknob types?
or the toaster, if you remember that analogy. Okay. Some of my kids did not understand that. But that's the difference between yours and mine. Okay. So, whoa! Look at that! Cosine of 3x is -1, so I am going to be looking at 3x equals the angle whose cosine is -1, which means possibly 2 solutions, maybe.
Maybe
I
even,
don't know.
Maybe even 3 solutions.
I don't know what's going to happen. So, the angle whose cosine is -1. There's only one place on the whole entire circle where x is -1, and that's right there. So that is what?
That is at pi.
Plus 2 pi k. Okay, I can get there this way, and I can also get there that way. So my other solution is now, frankly, I would actually have just done 3x equals plus or minus pi plus 2 pi k, but we'll go ahead like this. Oh, gee, what should we do?
Oh, we have to divide by 3.
So here's my x1, here's my x2, so x1 equals 1/3 of this entire mess. Show all of that in parentheses, please, or else we have to get upset with you.
Pi over 3 plus 2 pi over 3 times k. Okay, and for x2 we would get x2 equals 1/3 times negative pi plus 2 pi k, which equals negative pi over 3 plus 2 pi over 3 k. All right, well, this is great and all happy dandy, but this is the general solution. And we didn't ask you this here, but if we were to ask you to find the solutions from 0 to 2 pi, we would expect you to be able to do this. We could even do from 0 to pi. But
Should
normally,
we do 0 to pi?
Sure, why not? Well,
We did. No, 0 to pi is not nearly as
it's
interesting
not nearly as fun.
0 to 2
Now, normally between 0 and 2 pi, we would have one solution, right? Because it's only a pi. But based on the same idea as the graph that I had just shown you, instead of having one solution, we would have 3 solutions. So we should have 3 solutions between 0 and 2 pi.
So here we go. if this is what we were asked for, so we're going to let k equal 0. When k equals 0, x1 is pi over 3. That's a simple one. When k equals 1, x1 is pi over 3 plus 2 pi over 3 is, I'm going to go ahead and write that out. Pi over 3 plus, putting a 1 in right there, 2 pi over 3. So if x1 is 3 pi over 3, which is going to be pi. We might have to go on and see what happens when x is 2. Then x1 is pi over 3 plus 2 times pi times 2. So we're going to go ahead and actually step out and go, okay, that's 4 pi over 3. So x1 would be 5 pi over 3. All right, so let's look at our solutions. We had at pi over 3, 2 pi over 3, and 5 pi over 3. Kind of funky, weird. All right, that is the solutions if we were asked on the interval of 0 to 2 pi for that part of the problem. Now let's do this other part of the problem. So here, if k equals 0, x2 would equal negative pi over 3. That is not, oopsie, hold on. I ran out of room. Yeah, that's right. x2 would equal negative pi over 3 plus, when k is 0, that term becomes 0. That is not in the interval of 0 to 2 pi. So let's k equal 1. x2 would equal negative pi over 3 plus 2 pi over 3. And what's that? Negative pi over 3 plus pi over 3 is pi over 3. Oh, we already have that one, don't we?
Yes. In fact, in our general solution, if I add 2 pi over 3 to negative pi over 3, I get the solution x1. So all of the x2 interval solutions are going to be duplicates of the x1 solutions.
That's just for this problem, though. That's not usual.
It's not typical, but because of this problem, I would say it's because the difference is so small. It would repeat itself more frequently. Okay, so
once we've gotten through that, we can see that our values are repeating. I can actually, just to convince myself, let k equal 3. That would give me x2 equals negative pi over 3 plus 6 pi over 3, which is 5 pi over 3. And once I add to that another 2 pi over 3 for the next thing, it would be out of the interval. So those are all repeated, so here would be our answers. 1, 2, 3.
Okay, and back in our general solution.
I put this in the wrong place, by the way. Let's try putting that in the right place, because I was looking at that. Pi over 3, there's 1. One solution was pi. I was adding the plus 2 pi over 3 and putting the 2 pi. And here's the pi. And here is the 5 pi over 3. And notice that those are evenly spaced apart. Gee, I wonder how far along the circle that is. Guess what? That is plus 2 pi over 3. Gives us to that point. And then if I add another plus 2 pi over 3, that gives me there. And if I add, well, whatever, you get the point.
Okay, another thing is, so from this general solution, because if I add 2 pi over 3 to negative 2 pi over 3, negative pi over 3, I end up getting this solution right here. We can just say this is our solution.
Yeah, that actually does work for this problem. It's not like that for every problem, guys, so you do have to be super careful, okay?
Yep.
You have to be super careful. It has to do with the fact that you have pi and negative pi, and those were at the same places.
Yes.
Now, let's pretend the problem worked out, and one answer was pi over 2, and the other is negative pi over 2. That's not at the same place on the circle, so you do have to go through every single step.
All right. So go to section 9.4 and work 2, 8, and 14 without calculators. And here we are again. I hope you learned a lot. Tell us what you did learn, and give us a good question. And we have a test, number something, 5, coming up on May 1 and 2. All right. It's got the old material, the stuff from last chapter.
Last test, including the nice little logarithm problem.
Yes, please.
Type. Yeah. And then, because if you don't get that on this one, you are going to get barraged with mastery quizzes on that one type of logarithm problem. Okay?
Yes. 8-2, 8-3,
Our favorite section.
8-4.
No, we didn't do it.
Oh, I thought we did. Okay, 8-2 and 8-3. That's right. And 9-1 through 9-4. And that way, we're going to start doing chapters 10 material later. So we love you guys. And this is the last part of trig.
No, we have
No,
log
no
sines
more.
and cosines plus that neat
Oh,
project.
done with this. What are you writing? All right. Yes, please start studying now as opposed to later. All right, we love you guys. Bye.
Bye.